Well, hello, my mathematical geniuses. Now we are heading into the second half of this kind of larger unit called angles and triangles. And really, we shift our attention to trigonometry. Okay, so in the first half, we talked about different angles on a transversal, whether the transversal crosses parallel lines or just random lines. And then we spend some time talking about triangles and how to prove congruency and exterior angles and all of that fun sort of stuff. Okay, that was the first half of this unit. Now we're going to switch over to trigonometry. And the purpose of today is really just to make sure you're on the same page with the trigonometry that you should have covered in 10C. Okay, now maybe you covered it and you forgot it, or maybe because of whatever reason it didn't get covered in as good a depth as you wanted it to. So that's what today is all about. Is let's just review some of those key concepts, make sure you are solid moving forward. Okay, so labeling a triangle, first of all, opposite sides are labeled with the lowercase letter of the angle. Okay, and then the angles are labeled with the uppercase letter. So what I'm saying there is this is angle A. Opposite angle A is side A. Okay, now when we say opposite in math, what we're doing is we're putting our pencil in the corner of the angle and we're drawing away from it. Okay, so this is angle C, and opposite angle C would be side C. And then this is angle B, and then opposite angle B would be side B, like that, okay? So the sides get little letters, the angles get big letters, or capital letters, and then they're always the same. So opposite angle with opposite, or an angle with its opposite side would get the same letter. It's just that the angle would be capital and the side would be lowercase, okay? Okay, two big things that you have learned thus far when it comes to trigonometry. One is the Pythagorean theorem. This was introduced to you around grade 8 for most of you. And it says this, in a right triangle, so a right triangle means you have a 90-degree angle, which I've shown you right there. The hypotenuse is the largest side of the right triangle. It's also opposite the 90 degrees. The hypotenuse squared will equal the other two legs squared and added together. Okay, so what you'll notice here is I have the other two legs are called A and B here, and then we've drawn a physical square around length A, and a physical square around length B, and a physical square around length C. And what we're saying is the area of this square plus the area of this square added together will equal the area of this square, commonly and lovingly referred to as C squared equals A squared plus B squared. What you got to remember about this is C squared is the hypotenuse. The letters themselves don't really matter. What matters is you realize that the hypotenuse has to be by itself, okay? All right, good. And then last year, we introduced the concept of trigonometry and SOHCAHTOA. Now, SOHCAHTOA is just a quick way to remember all the ratios of a triangle. And I've listed them here for you. So the sine ratio is the ratio formed by going the opposite side of angle theta divided by the hypotenuse of angle theta. Remember, opposite is you put your pencil in the corner and draw away from it. The cosine would be the adjacent side divided by the hypotenuse. So the adjacent means touching or beside. So the adjacent angle is the one that is part of the angle, but not the hypotenuse, okay? So if I drew this triangle right here for you, and we were looking at theta here, this would be adjacent to theta, this would be opposite to theta, and then this would be the hypotenuse, assuming that you were given that that was a 90-degree angle there, okay? And then tangent would be opposite over adjacent, okay? So SOHCAHTOA is just a quick way to try and remember that. Sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent, okay? All right, good. So let's try something. Solve the following triangle given that angle W is 90 degrees, round all values to the nearest tenth. Now I'm just going to hide my head for those of you who don't have the book in front of you and want to see that question. Now, when we say solve the triangle, we are saying you want to find everything that's not given to you. So when I look at this triangle here, that means I want to find angle A. Sorry, not angle A, side A. And I want to find angle A, but I had written side A. So I want to find side A, I want to find angle A, and I want to find side or angle T. I already know angle W because that was given to me right here, right? Okay, I'm going to go for side A first. I have two sides of a right-angled triangle. So I'm going to use the Pythagorean theorem to get the third. Now I have the hypotenuse. So if I start with c squared equals a squared plus b squared, my c has to be the 11. The a and b don't matter. So I'm going to say 11 squared equals 7 squared plus a squared. Okay. Now 11 squared is 121. 7 squared is 49. And then to get a squared by itself, I'll have to subtract 49 from both sides. That's going to give me a squared equals 72. Okay. You were asked to round to the nearest tenth, so I'm going to take the square root of 72 and get 8.5 when rounded. So now I know that side A is 8.5 centimeters. Now I'm going to go for angle A. If I go for angle A, that means this is the angle I'm looking at right now. So this would be my adjacent, and this would be my hypotenuse. So I have the adjacent and the hypotenuse. I'm looking for the angle that goes with the adjacent and hypotenuse. If I think through my SOHCAHTOA, who uses adjacent and hypotenuse at the same time? Well, that's cosine. So I'm going to say cosine of A is 7 over 11. Okay, cosine of A is 7 over 11. So now if I want A by itself, I have to take the inverse cos. That looks like this, okay? A will equal the inverse cos or the arc cos. Both of those mean the same thing, of 7 over 11. And then you're going to type that in your calculator. But friends, just be careful. We haven't had to have this conversation yet together. You need to be in degree mode right now. And most of your graphing calculators by default will not be in degree mode. They will be in radian mode. Okay, so if you are a Casio, you are going to press Shift menu to get into your setup features. And then you'll notice right at the bottom of your screen, you have an option that says angle, and then you will press F1 for degree. Okay. If you are a TI kid, you'll press the mode button on your calculator, and then you'll go down 3 and over 1 and hit enter so that the word degree there is highlighted. Okay, then you won't be in radian mode. So provided you are in degree mode, you should get 50.5 degrees for angle A. Okay, now some of you are going to say, oh, okay, now let's get angle T by just going 180 minus 50.5 minus the 90 that I know. If the 50.5 is right, then you'll be right. But if the 50.5 is wrong, then you're going to be wrong. And I wouldn't take that gamble, okay? Always try and use only the things that were given to you. So if I was going to play this game and only use the 7 and the 11 because they were given to me, now I'm looking for angle T. The 7 will become my opposite. The 11 will still stay as my hypotenuse. So I'll be looking at opposite and hypotenuse. If I think about SOHCAHTOA, who uses opposite and hypotenuse at the same time? Oh, it's sine. So I'm going to set this up as sine of A is 7 over 11. And then just like I did with or sine of T, sorry, I said sine of A. That was silly. Okay, sine of T is 7 over 11. And that means T will equal the inverse sine of 7 over 11. And then T will be 39.5 degrees when I put that in my calculator. Now, as a check, you can look at this and say, oh, these two numbers here should definitely equal 90, because then I'll add it to this 90 here and get 180. okay? And they do, so everything is wonderful. All right. Couple of definitions for you, the angle of elevation and the angle of depression. The angle of elevation is an angle between a horizontal line and the line of sight when looking up at an object. Well, an angle of depression is the angle between the horizontal line and a line looking down at an object, okay? So angle of elevation or inclination, sometimes you'll hear that called, is going up. I'm just gonna hide myself so make sure you can see those pictures. And an angle of depression is an angle that is going down. Now, what you have to be careful of is in both of these, they have to form with the horizontal line. You see that that's forming with this, that was a really bad horizontal line, but you can see it's forming with that horizontal line. And you see here, it's forming with that horizontal line. Okay, angles of depression are usually harder to deal with because what I want you to notice is when we form with that horizontal line, it's not in the visible triangle that you see. Okay, but hey friends, we just did a talk about parallel lines and a transversal that goes between them. And look at that, the angle of elevation and the angle of depression will actually be the same thing because they're alternate interior angles. Isn't that fun that it comes back in this lesson? They're alternate interior angles. So if you have the angle of depression, you also have the angle of elevation, and vice versa. If you have the angle of elevation, you also have the angle of depression for the same scenario. Okay. Awesome. Okay. From the window of one building, Sam finds the angle of elevation to the top of a second building to be 41 degrees. The angle of depression to the bottom is 54 degrees. The buildings are 56 meters apart. Find the height of the second building to the nearest 10th. Okay, so I've given you a picture here of two buildings. I'm just going to hide myself for 1 sec so that you can see the picture. And we're going to put Sam somewhere in here. It doesn't really matter where, but wherever I put Sam, then I'm going to label the angle of elevation up to the top and then the angle of depression down to the bottom. Okay, so what I'd like you to do is pause me and go ahead and get that picture yourself first. Okay. Okay, so we should have something that looks like this. So I have Sam sitting right here, and then the angle of elevation going up is 41 degrees. Remember that angles of elevation and depression have to form with a horizontal line. So there's my horizontal line. The angle of depression going down will be 54 degrees, and the buildings are 56 meters apart from each other. So what do I know? Well, I know that if that's 56 down here, I also know that this will be 56 right here, right? That's important because then that gives me this common side to both of these triangles. I have enough information to figure out what my x value is, which would be the distance from here to here. And I have enough information to get my y value, which would be the distance from here to here. And then the height of the building, I would just add those two things together. Okay, so if I'm looking at, let's start with x. If I'm looking at that 54 degrees, this would be opposite, and my 56 would be adjacent. So who uses opposite and adjacent? I'll go SOHCAHTOA to try and figure that out. Oh, tan uses opposite and adjacent. Okay, so I'm just going to clear my ink here, and we're going to say, okay, so tan of 54 degrees is x over 56, opposite over adjacent. And then if I'm solving for x, I'd multiply both sides by 56. So x equals 56 times the tan of 54. And that works out to be 77.07739. Now, I know I gave you rounding instructions. I think I said round to the nearest 10th. Don't yet, because we're in the middle of a question. Okay, you don't want to follow those rounding instructions until the very end, or you're going to run into a little bit of a rounding error. Okay, then I can do y as well. So I'll have, again, this is opposite, this is adjacent, so it's still using tan. Tan of 41 degrees is y over 56. And to get y by itself, I will go 56 times the tan of 41. And that's going to give me 48.68006. So now all I have to do is add them together. Now, take a look at what I did. I actually left them an exact value, and that's what I typed in my calculator. If that's stressful, don't worry. You can just take the 77.07739 and add the 48.68006. Okay. Either way, you should get 125.8 meters. Okay. And then we'll conclude the height of the second building is 125.8 meters when rounded to that 10th place. Okay. All right, my friends. So that's it for today. Just a matter of you getting on the same page with all of the beautiful trig things that we did in 10C. Okay. So for those of you who are my kids at school, I've given you your homework here. Make sure you're doing it and make sure you're asking me lots of questions. You know where to find me. All right. You guys got this. Next up is an exciting thing called the sine law. Okay, so we'll talk about that next. First, take some time to get comfortable with this. I'll talk to you soon. Take care.